So same thing, 25, 169, 13, found our x. And was this a Pythagorean triple?
Yeah.
Yes. All right, here's another one. Find the value of x, tell whether the side lengths for Pythagorean triple. So same thing. I always like to set up a visual of what I'm putting in. So what's my a and b this time?
7 and x.
So I've got 7, and I've got an x.
That's also 6.
We're going to do that. There we go. And then my c is going to be
14.
14. So we got 7 squared
What?
plus x squared equals, what's that? What's 14 squared?
14 squared. 196.
196. Now what do we have to do now?
Subtract.
Subtract 49 from both sides. It's like coming back to algebra, solving your equation. Remember that cancels out. We're left with x squared equals what? What is it, 147? Yeah. All right, and then our last step is always to take the
Square root.
square root. X equals what?
12.1243565.
Okay, so instead of taking that crazy decimal, let's just break down this square root. So if we have a square root of 147, what factors multiply to give me 147? There's 2 of them. So I know that 49 times 3 will give me 147. And I know that 21 times 7 will give me 149. If I'm trying to break down the square root, I want something that's going to be a perfect square root.
49 and 3.
So we're going to use these guys, right? Because 49, take the square root of 49 would be what?
7.
7. So I end up with 7 times the square root of
3.
3. This one can also be broken down because 21, what's factors of 21?
3 and 7.
3 and 7, right? So that means I would have this, right? So then these two would end up bringing me back to 49 times 3, and it kind of just brings you right back to that one, right?
Okay.
Questions, comments, concerns? Am I going too fast? So this would be like simplest form. That's what they want. Unless they ask you for a decimal, then you put it in a calculator and you'll take whatever they want you to round it to. All right, let's look at a skyscraper. So a skyscraper shown is connected by a skywalk. So there's your buildings, there's a skywalk, and then the support beams are holding up each side. All right, so it forms a right angle, so it's a right triangle. Find the length of each of the support beams. So how would you set this up? What would be my A, my B, and my C?
23.26 and 47.57 for A and B.
A and B, so 23.26 squared plus 47.57 squared equals C squared. Breaking it down, it turns into, I think I got this, plus 2,262.49 equals C squared. And we add them together, you end up with
2803.9325.
hate decimal. That equals C squared. And then you have to take the square root of that, which ends up bringing us down to a,
52.95 to 1722.
we're just going to say about that. Questions, comments, concerns, how to find your A, B's, and C's. You know this is your right angle, right? So we knew these were the legs because our hypotenuse is the diagonal. All right, try 1, 2, and 3 of the self-assessment. Please and thank you. All right. Let's see. Has anybody, raise your hand if you have an answer for number 1. What you got over there? It says which is different, find both answers.
What is the value of square root of a squared plus b squared?
So what is the value of this one right here?
Yeah.
Square root of a squared plus b squared. What do you think they're asking you to find? Which would be what?
C
They're
squared.
asking you to find c. All right. What do you think this question's asking? Raise your hand. What is the length of the hypotenuse? What are they asking you to find? Raise your hand up. What letter is that?
C.
C. What about this one? What is the value of c? Obviously, they're asking you to find c. So which one's different? Right? What's the value of a squared plus b squared? Because they're asking you to find what? C squared. Raise your hand if you got number 2. Do the side lengths of a right triangle with a hypotenuse of 15 feet and a leg length of 9 feet form a Pythagorean triple. Yay or nay?
Yeah, it can be.
Yes, it does. Because it turns out to be a what? A 9. What was your answer?
9, 12, and 15.
9, 12, 15. Anybody get 3? Anybody try 3? So real quick, it says this device is used to measure wind speed. It's attached to the top of the pole. The support wires are 5 feet. So they're saying what's 5 feet? The diagonal or the pole?
Pole.
The pole. Pole's 5 feet. So that's my 5. That's my 6. So that means this would be another leg. Plug it in. We got a squared plus what? 5 or 6? 5 equals 6 squared. 25 equals 36, right? You subtract your 25, you end up with a squared equals, what did I get? 11, right? Take the square root of both sides. Is there a square root for 11?
No.
No, so we can just leave it as
The square
a
root.
equals square root of 11, unless they ask you for a decimal. Questions on those 3? Are we okay? Okay. Okay, so now using the converse of the Pythagorean theorem. The converse of the Pythagorean theorem is also true. So you can use it to determine whether a triangle with given side lengths is a right triangle. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the length of the other 2 sides, then the triangle is a right triangle. Right? So c squared equals a squared plus b squared, then that triangle ABC is a right triangle. Does that make sense? So let's try verifying right triangles. So tell whether each triangle is a right triangle. So let's look at this one right here. A. We've got 8, 7, and the square root of 113. How can we figure out which side is the biggest side? What do we need to do to that? We need to simplify, right? So what would 113, square root of 113 be? About what?
Like 10.1.
10.5 or 6?
Yeah.
So that means this would be the longest side, right? So that would be our C. So let's set it up. We've got the square root of 113 squared equals 7 squared plus 8 squared. What happens to this over here because it's a square root being squared?
It cancels out.
Cancels out. So we end up with 113 equals 49 plus 64. Add it together. It says 113 equals 113. So what does that mean for us? Is it a right triangle?
Yes.
Yes. Yay, it's a triangle. All right, let's look at the side. B. So now we've got a little bit different kind of a square root here. So now this square is being distributed into this parentheses. So both of these are being squared. Does that make sense? So your 4 is being squared and your square root of 95 is also being squared. So we're going to break it down like so. 4 squared, 16. Remember, for squaring a square root, that just cancels out. We're down to 95. So now we've got 15 squared, 225, plus 36 squared, 1296. So now we're going to multiply these two, remember, because it was multiplying. We end up at 1520 equals 1521, which doesn't equal 1521. So would that be considered a right triangle?
No.
No. This needs to equal each other. That's all it is. Working through the equation and making sure it makes sense. Questions, comments, concerns? Cool beans. All right, can you try 4, 5, 6 and tell me if they're right triangles or not? What's that? Are we ready? Looks good. Okay, let's run through this real quick. 4, raise your hand. What you got?
Yes.
Yes, it is a right triangle. Anybody else got different? No. Okay. 5.
No.
No, it's not. Anybody else got something different? Are we good? All right, awesome. 6.
Yes.
Yes. So yes, no, yes. Questions? You want me to work anything out? Good? Awesome. All right. So classifying triangles. So the converse of the Pythagorean theorem is used to determine whether a triangle is a right triangle. So you can use this theorem below to determine whether a triangle is acute or obtuse. So instead of seeing it as a squared plus b squared equals c squared, you're going to see it a little bit backwards, where the c is going to come first. Okay, so for the Pythagorean inequalities theorem, for any triangle ABC, if c is the length of the longest side, the following statements are true. If c squared is less than a squared plus b squared, then your triangle ABC is going to be acute. Does that make sense? So if c is smaller, it's acute. It's a small angle, small triangle. If c squared is going to be larger, so greater than a squared plus b squared, then triangle ABC is going to be obtuse. Make sense? C is greater than, bigger angle, obtuse triangle. Questions? Determine whether segments with lengths 4.3 feet, 5.2 feet, and 6.1 feet form a triangle. If so, is the triangle acute, right, or obtuse? So we're going to use that theorem we just talked about, right? So remember, the triangle inequality theorem states that the sum of the lengths of any two sides of the triangle has to be greater than the length of a third side. So does this even form a triangle? Well, let's try. 4.3 plus 5.2, 9.5 is greater than 6.1, so we got one yes. 4.3 plus 6.1 is greater than 5.2, plus 6.1 is greater than 4.3. Yep, so all of these do make a triangle, so we know it makes a triangle. Next step, is it acute, right, or obtuse? Well, let's plug in our numbers. We know that what side would be my C? My largest number is 6.1, right? So there's my C. My A and B are going to be right here. Square them out. 18.49 plus 27. We end up here. So our inequality means that C is less than a squared plus b squared. So what does that mean? If it's less than, it's going to be what kind of triangle?
Acute.
An acute triangle. Less than, acute, greater than, obtuse. You want to try it? Yeah, you do. Try 7, 8, 9. Determine whether the segment lengths form a triangle. So you have to do what? We're going to add them together, all of our side lengths. So 7 is greater than 6, right? So go through your thing, make sure it makes a triangle, and then yes or no, and then once you get that, determine if it's a right, acute, or obtuse triangle. So 2 answers for each of them. Okay, don't wanna rush you. But are we ready? Anybody got number 7? Raise your hand. Yeah. Yes is a triangle, yes or no, and then what kind of triangle is it?
Yes, obtuse.
Yes, it's a yes and it's an obtuse. Questions on that? No. Awesome. What about number 8?
Yes, acute.
Yes and it's what?
Acute.
Acute? What'd you get?
Obtuse.
It's only one more. What's left?
Right.
It's a right
If
triangle.
you're really paying attention, ladies and gentlemen, it's a Pythagorean triple, even though it's not integers. Because 2.1 is 0.7 times 3, 2.8 is 0.7 times 4, and 3.5 is 0.7 times 5. It's a 3, 4, 5 multiplied by 0.7. So it's actually a Pythagorean triple, even though they're not integers. But that's using that knowledge would help you. If it was 21, 28, 35, it would have been a Pythagorean triple. And you just don't let the decimal get in the way.
And this gives you 1225. And then the last one, number 9. Raise your hand. Anybody? Is it a triangle? If so, what kind? It's not a triangle. All right. Can you take your computers back out and go back to that website for me?
But you have a new code, right?
New code. That quiz. .org. Bottom right hand corner. So now that you know all this fun stuff, that's an O, 4, Z, I, 2, U, 4,